Hi, everybody. I just wanted to quickly talk about simulations and if they aren't working and whatnot. And some of the things I've just noticed from the tutorials and helping you. This is not meant to necessarily do that much for you at this stage, but if it can, then that's great. The main idea is that perhaps for the next phase, if you're struggling with something, and this might help you to learn how to kind of problem solve and find issues when working with a simulation. Right? I can just say that if you're working with a base script that is working for everybody else, and if that script isn't functioning for you, um, my guess is that the issue is probably not with the script in most of the cases. There might be some, like for instance, installations not being correctly done on your computer specifically, or maybe that you don't have the right type of format for the models you put in or whatnot. Or there might be some weird setting if you've been like playing around with the script or so. But in most cases, if it's working with the original model and the original script, then the script should be somewhat functioning. Right? So in most of the cases I've seen, there have been an issue with the model or inside of the Rhino file. Um, and so when you're looking at that, there are a few things that I'd like to just mention. First one is meters. This is the unit, right? And if you have some other unit than meters, consider maybe just changing that to meters, or maybe even like moving your geometry to a file that is starting with meters as its unit, because the Honeybee and Ladybug script is primarily doing its calculations with the preconceived notion of you using meters. And if you're not doing that, it might create issues, right? So some people had, or one group had an issue with that, for instance. So that's a very easy fix, right? That can really create issues potentially. Another thing is to consider that most simulations, from what I can see, um, do function with extrusions. I think extrusions have one benefit in general, and that is if you know that this is an extrusion, it's probably like closed. You probably don't have like really like super weird things happening. And what I mean by weird things happening is, imagine you're just working with different surfaces. Actually, like let's explode this one. Right? It's all surfaces, and you're like trying to close a surface, and you kind of accidentally happen to miss something or make a mistake of some sort, right? It can happen so easily, like trying to reach the end and then you know not getting it fully shut. And most of the time, this probably won't matter too much, right? Um, Most simulations are somewhat robust enough to be okay with that, but sometimes it can mess up the script. It can add like these extra layers of complexity that just like breaks everything. Right? So if you can, try to find ways of ensuring that um, most of the parts of the simulation is simple, and that's kind of what it comes down to, right? It's about making sure that it's simple enough for a simulation, and because the simulation is still just a simulation, right? It's not precise in that sense, and it's mostly there to give you a general idea of what are the conditions right now. Another thing to just have in mind is the difference between meshes and reps. lines and splines. And so, for instance, a line, it's basically um, defined by 2 points in space, and the line is in between those, right? Whereas a spline is kind of like a approximation, right, of these 2 points. So it has a degree, and it's defined through a mathematical formula, at least a more complex one than line. And to reference that in 3D geometry, right? This is a prep, whereas and let's say if we're using something more complex like a cone here, you see that this cone is perfectly defined. It's very sharp. Whereas if we do a mesh cone, we're going to notice that this mesh cone, it's not perfect in the same sense. It's not perfectly round, right? It's jaggedy. And the mesh, in the same way as a simulation, is kind of approximation of reality. It's made out of little surfaces, usually triangles, and each of these triangles or surfaces are always straight. And meshes are great because since they're approximation, they're usually a lot lighter than a prep if they aren't like super complex and whatnot. So to define the same type of geometry, a mesh is almost always lighter in what information it holds. And that makes it great for simulations, right? And that's why Honeybee and Ladybug is based upon a mesh model as far as I'm concerned. So what that means is that any type of geometry that you put into Honeybee or Ladybug will eventually become something mesh-like, like surfaces, right? So, so if you put in a prep, let's say this prep, Ladybug will have to remake that into a mesh, basically, and that might be fine in most of the cases. It's quite good at doing that. However, if we look at, for instance, this example file, and let's say, yeah, let's turn on. What we can see, let's say here, is that you get these approximations, these surfaces. So if you want these panels to be well defined by yourself, then I would try to remake something for a simulation as a set of lines or splines or whatnot, instead of using splines, so that you have more control. And in most cases, this shouldn't be an issue. But if you're having an issue, like this could be a reason, like that the translation from something rounded, something spline-like, to something that is more like mesh-like, something that is more from prep to mesh, that conversion isn't working well. So that's something to just consider as well. Something that might be even more relevant, actually, for most people, is the idea of reducing complexity when trying to deduce the issue. So imagine, like, let's make an array here, and imagine this is your site, and you have a few buildings here in the middle or something that are just bigger. Scale on D. Right. So these are your buildings, and now you want to do a simulation of something, and you're realizing, okay, this isn't working. I have no idea why. Um, what I would do, right, is start doing a simulation of this part. If this doesn't work, then you're like, okay, if this little part doesn't even work, if like these two buildings doesn't work, then we know there's a larger issue here, because this simulation doesn't work at all right now. Um, but if it works, if this little part works, then you know that, okay, this works. The issue is somewhere else. But that also means that you can slowly but surely kind of include more and more of the model and see at what point it breaks. Sometimes you might be able to add the entire like part of what actually matters, which usually is the closest surrounding buildings and your own buildings. And a lot of times the other parts of the vicinity doesn't even matter, right? So just adding that part might be more than enough. And in those cases, well, then you didn't really need to, simulate all of that. And maybe it was just too much information and just called down the simulation, right? Then you're totally fine. So trying to break it down into smaller and simpler steps. Another thing, of course, and also if you're having these like super like too much information in your model, you're modeling everything in the most complex ways, and you're having each beam and whatnot. Like if that's the case, just make it more like into a basic geometry, right? And that will probably help in most cases. So that's just some things that might be good to think about. And some other things to perhaps consider is also looking at where the script breaks. And for example, either using panels to understand what is the information we're getting. This isn't necessarily something that's super easy unless you have a little bit of experience, especially if you're getting like not enough information. But in a lot of the cases, you can actually get a great deal of information. Like here, I see, okay, we're getting 16 different preps, right? So I know what type of a model it is. I know the quantity. And if I see some weird stuff happening here, like maybe it says non-object, or it's like a number or a 0 or something, then I might know, okay, there's something weird happening here, right? Another thing to consider is that it's not always that legends make sense. You can adjust the color. One way of doing it, of course, is by adding more colors and whatnot to what already exists. You can also do it by, for instance, just making multi-line data and just let's set this to 0, and like for instance, and just like plugging it in, right? And then you can set your own color gradients by just like adding numbers, right? You can also consider what ranges you're working with. Right? In this case, 0 to 100, that might not fully make sense, because, for instance, with a vertical sky component, the max for a vertical wall without any slope is 40%, because like if you're in this window, you're not gonna be able to see the entire sky, right? Because you have ground. Like if it's a skylight that's facing directly upwards, you can see 100% of the like sky dome. Not possible from a window. So going all the way up to 100% just kind of doesn't give you that much information beyond 40%. And then you can have a legend that is, well, quite a lot bigger and might describe more of the conditions. And especially considering that from like everything above 26%, that's like good values, right? That's like really solid stuff. And so it's actually like all these kind of different grades below that actually start matter. And if anything, perhaps 15% would be an important kind of part to kind of show, since below 15% tends to be somewhat not great, or maybe at least, and so it's something to at least think about and maybe read up on. I'll send some more information later about this. And yeah, I think that's the main things I wanted to just talk about. Hope it was somewhat informative, and I'll see you later.